morning. In the first lecture of Dynamics of Machinery, I have given the introduction part, and we have also discussed about the difference between kinematics of machines and dynamics of machinery. Then we discussed about the total contents in the course of 6 units, and I have given brief introduction on each unit. Then I have just started in the last lecture the first unit, gyroscope, and briefly I explained it. So for the benefit of the people, those who did not attend it for the yesterday's class, it's my duty, it's a new session, so to introduce a little part about the curriculum and the contents in the first unit. The first unit is gyroscope, and in this first unit we are dealing with what is gyroscope and how we can represent vectorially the gyroscopic couple, and what is gyroscopic effect and how this gyroscopic effect is going to be applied on practical devices on moving bodies like aeroplanes, on ships, as well as four-wheeler, two-wheeler. So, in nutshell, what we are going to discuss in this unit is the basic concept of gyroscopic couple and the gyroscopic action and gyroscopic effect, and practically how we can apply this gyroscopic effect on moving bodies named as aeroplane, ship, as well as four-wheeler and two-wheeler. Okay. Let us start with how the word gyroscope has introduced in dynamics of machinery. If you look at the history of mechanics, especially kinematics and dynamics, during 16th, 17th centuries, the people like Newton, Kepler, and other eminent people in this field, they have made lot of experiments on simple children playing toys, and they derived and they developed a beautiful laws like Kepler laws and other laws related to the spatial bodies which are moving in the space. Similar way, this gyroscope was also, this effect was identified by the scientists during 16th century just by an observing a simple top which is moving on the ground. Okay, when it is running with its full speed and it is stably moving, whereas when its speed is going to be reduced, then it is giving a motion like wobbling motion. And that is a simple thing they have observed, and at the same time they have also seen so many children playing toys which give some effects. People are not aware of it, how it is happening. Then they have recollected there is something behind it. So you are all aware of it, how the Newton has invented the gravitational force concept. When he was sitting near to a tree, that is apple tree, and he observed an apple was falling from the branch towards the ground. Immediately he got a simple idea like how the apple is dropping down, why not it is moving up? So there is something involved in it. that is the concept of gravitational force came into the existence. In a similar way, the principles of gyroscope also have identified by observing various discs spinning its own axis, and when you are trying to change its axis, what is going to happen, that was noticed and that was coined with an effect called gyroscopic effect. So now let me come to the basic word gyroscope. This word of gyroscope was originated two Greek words, gyros as well as scopian. What is gyro? Gyros is nothing but a circle, and scopian is nothing but to look at. That means a circular motion, watching, is nothing but a word called gyroscope. So in nutshell, a gyroscope can be defined like this. It is a device which is used to measure or maintain certain orientation based on the angular momentum principles. It's a simple device. It can be used for two different purposes. The purpose one is to measure the orientations of a body or to maintain the orientation of the body in a stable way with the help of a device called gyroscope, and that gyroscope works on the principle of angular momentum. Okay, we will see how this gyroscope and how this angular momentum can be applied for the basic principle which we have stated here. If you look at, I have given a simple animation here. This animation is an animation corresponding to this object. This object is nothing but a gyroscope. It looks like very simple, nothing is there. You can see in this what is there. There is a rotor which is mounted on a spindle. And this spindle is fixed on this gimbal, inner gimbal, and this inner gimbal once again mounted on another gimbal which is perpendicular plane to this inner gimbal. This gimbal once again placed in the outer frame, gyroscopic frame, and the entire frame is mounted on the stand. It's very simple, very simple. There is not much ambiguity or complexity in the device. It's a very simple. There are 3 rings and 1 disc. You can see here, this is the center rotor which is rotating, and then you can see the inner gimbal and outer gimbal and outermost the frame also revolving. So we can say simple words like this: a gyroscope is nothing but a spinning wheel or a spinning disc whose axis is free to rotate to take any orientation. So this device, once it spins, it offers certain resistance to change its position, isn't it? So it offers some resistance to change it. So when you want to change its position, okay, then you have to apply a force, you have to apply a force, then only it will change its direction. Okay, so this phenomena is a beautiful phenomena which it is going to happen, which is not imagined by us, isn't it? That means when this rotor is rotating with its own axis, if you are giving a angular displacement for this rotor, then this rotor not simply moving in that direction, but it also moves in the third direction other than its own direction. That is the beauty what you can observe in a gyroscope is concerned, isn't it? Let me repeat once again. It is a simple rotor which is rotating with its own axis, that is called spinning with its own axis, and this rotor, if you give some amount of angular displacement, then that rotor will move in the third direction, which is not its own direction because of the gyroscopic effect. So let us see the gyroscopic effect, how we can explain by various terminology like spin, precision and torque. Okay, as I said earlier, the rotor rotates its own axis, which is called spin axis. You can see here I have taken a rotor. The rotor is rotating with its own axis, and when I look at from this direction, this is rotating in a anti-clockwise direction. It is rotating in a direction, anti-clockwise direction. When this rotor is rotating in an anti-clockwise direction, this rotor, if it has to be given an angular displacement of delta theta, then it occupies a new position here. When it moves into a new position, that is at this location, this spin axis is shifted to another line. Here this spin axis is shifted. Okay, then to provide this motion, we have to apply a force, otherwise this will not move into another location. You are aware of the Newton's first law, that is, a body will continue its own state of motion until and unless we apply some external force. In a similar way, you can see I have to apply certain force. So when I apply this force, this body, this rotor changes to another position here. How I have to apply? I have to apply a force like this. If I apply a force like this, then only the rotor will go there. So if I apply this force like this, you can see my thumb is a vertical direction, which is nothing but precision. This is axis of precision. So this is axis of spin. This is axis of precision. Then the force is applied in this plane, that is this direction. This is the third direction. The couple is applied, that is gyroscopic couple, isn't it? So this gyroscopic couple are also called as a gyroscopic torque. That is what we call active gyroscopic couple. And active gyroscopic couple. Like centrifugal force and centripetal force, how a force which applies externally and which applies inward, outer and inward, that is active and reactive. Similar here also, active gyroscopic couple and its opposite is reactive gyroscopic couple. It is reactive gyroscopic couple. Okay. Our objective is basically here to discuss about the outcome of the reactive gyroscopic couple. So whenever we say the effect of gyroscopic couple means not due to active gyroscopic couple, it is due to the reactive gyroscopic couple. So here whatever I have explained, I have stated once again here. So a body is spinning its own axis, isn't it? And it is given an angular motion about an axis perpendicular to the axis of spin. Then there is an angular acceleration acts on the body about the third perpendicular axis. Whatever we discussed there, the same thing has coined here in the statement. A body is spinning its own axis and that body has given an angular displacement, okay, that is perpendicular to the axis of spin. Then there is an angular acceleration induced in the body which is perpendicular to the another axis, that is the third perpendicular axis. So the torque required to produce this acceleration is known as active gyroscopic torque. The torque required to produce this is called active gyroscopic torque. Then the reaction due to this, that is opposite to the active gyroscopic torque which we obtain, is nothing but gyroscopic effect. This is what we call gyroscopic effect. Now I will discuss about how to find out a spin axis and precession axis. Spin axis and precession axis. For this we apply a rule called right hand screw rule. Right hand screw rule. What is this right hand screw rule? Let us see. Let me take a rotor which is rotating with the help of a shaft, and if I look at from this direction, this can rotate either clockwise or it can rotate counterclockwise. First let me explain the case 1, which is it is rotating clockwise direction. By applying the right hand screw rule, how I can notice my right hand thumb rule? Let us see. This is my right hand, this is my right hand. Keep your 4 fingers of your right hand in a direction of the rotor. Now first I am discussing the clockwise rotation. Clockwise rotation. Looking from this end. Looking from this end. So look me like this. This is the 4 fingers rotating in this direction, clockwise. Then my thumb is indicating towards left. My thumb is indicating towards left. Then the spin vector is simply represented like A to B. A to B. Take another case, counterclockwise rotation. I look at from here, then the rotor is rotating counterclockwise, looking from this side. Look at from this side. These 4 fingers are representing the rotation of the disc. Then my thumb, which indicates towards right, is my spin axis, that is B to A. I hope you are clear to draw the spin axis by applying the right hand thumb rule. Let me repeat once again the right hand thumb rule. Keep your right hand such a way that the 4 fingers of your right hand indicating the sense of rotation of the rotor. In my case, I have taken first case, case 1, the rotor is rotating clockwise, looking from the end A. End A. So when I look at from end A, the spin axis is moving towards left, that is A to B. That is the case 1. Then case 2, rotating counterclockwise. Like This is the counterclockwise direction. Looking from this end, this is my A end. Then the thumb is indicating towards right, which is spin axis like this. Okay. Now, let me introduce the precession axis identification. Say this rotor is rotating vertically with an angular velocity of omega like this. This rotor is required to move its angular displacement in a path like this. So, if this rotor has to be shifted to another position called OX direction, then what type of force I have to apply? I have to apply a force of AB. I have to apply a force of AB. But the force where I apply at the end. So there is a distance from end to the center, that is the radius. Then force into distance becomes couple. Then that is the applied couple AB. So when I apply applied couple AB, as I said earlier, there will be a reactive couple which acts on it in the opposite direction is BA with a dashes B dash A dash. Okay. Then how to identify the precession axis? When I want to move this body, the force to be applied like this. When I apply this force like this, my thumb is indicating in a vertically upward direction, which is nothing but precession axis. This is my precession axis. Then the third perpendicular axis is this one. This is gyroscopic torque axis or couple axis. So these are the three mutually perpendicular axes: spin axis, precession axis, and gyroscopic torque axis. Okay. Now let us see how to find out its angular motion and how to find out its angular displacement and other mathematical analysis part. As I have stated already in the previous slide, when the rotor is rotating like anti-clockwise direction looking from this end, my spin axis is towards like this. And this rotor initially rotates with an angular velocity of omega, and given an angular displacement of delta theta, now the angular velocity has changed to omega plus delta omega, isn't it? Then at that moment, the new spin axis is OX dash and its angular velocity is omega plus delta omega. So if I represent my spin vector in the two situations, one is OX and another one is OX dash. Okay, so you can see the change of angular velocity, the vectorial term is omega plus delta omega minus omega. This is nothing but simply delta omega you get. Omega initially, omega plus delta omega finally, then the difference of it is omega plus delta omega minus omega, which is nothing but delta omega. This can be resolved in two directions. One is parallel to OX and another one is perpendicular to OX. One is parallel to OX, that is its X component in the radial component, this is XR, and the perpendicular component is RX dash. These are the two components, XR and RX dash. So if I calculate the angular acceleration in the direction of OX, how the angular acceleration in the direction of OX is equal to, this is XR, the displacement along the X direction, by in a time interval of delta t, XR by delta t. So XR can be written as OR minus OX. OR minus OX by delta T. How we can write OR from this OX dash R triangle? OX dash R triangle. OR can be written as OX dash this cos delta theta. OX dash cos delta theta minus OX by delta T. Then what is OX dash cos delta theta? We are aware of it. OX dash is equal to omega plus delta omega into cos delta theta minus omega by delta T. So if you expand this term, this gives omega cos delta theta plus delta omega cos delta theta minus omega by delta T. Isn't it? You can see once again, XR is the displacement along the OX axis, delta T is the time interval, then OR minus OX by delta T, then it gives omega cos delta theta plus delta omega cos delta theta minus omega by delta T. We have taken a small angle delta theta, isn't it? So with a small angle of delta theta, cos delta theta can be written as 1. If the cos delta theta becomes 1, then this first term will become simply omega. Then here this becomes a delta omega. Then as it is omega by delta T. So omega get cancelled. Then it will be component of angular acceleration in the direction of OX is delta omega by delta T. In a similar way, I will take the component along vertical direction, which is nothing but alpha T is delta omega, the previous part. If I apply the limits, then it becomes delta omega by delta T is equal to d omega by dt. Then the component angular acceleration in the direction perpendicular to OX, that is Rx dash by delta T. Rx dash is nothing but OH dash sin delta theta by delta T, and this is omega plus delta omega into sin delta theta by delta T. For a small value of delta theta, sin delta theta can be written as delta theta. Then this becomes omega delta theta, then delta omega delta theta by delta T. So two smaller quantities, delta omega smaller quantity, delta theta. Then this product is neglected, then it becomes simply omega delta theta by delta T. When I take delta T is a small value, then this alpha C is equal to omega delta theta by delta T. It can be replaced by d theta by dt, where d theta by dt is called as precessional angular velocity omega p, that is omega into omega p. So the total angular acceleration is sum of along OX direction along Rx direction, that is vector xx dash is equal to d omega by dt, then omega d theta by dt, that is simply d omega by dt plus omega p. Okay, so I will summarize what we have discussed in today's lecture like this. I will summarize the thing. First, we have discussed about the origin of the word gyroscope, which is derived from the two words these two words. Okay, then we have discussed about spin axis, precession axis, and gyroscopic axis, and we also discussed about the effect of gyroscopic effect, that is opposite to the active gyroscopic action. Then we have derived the angular acceleration, which is nothing but d omega by dt plus omega omega p. Okay, in the next lecture we will discuss the actual case which we derived applied to a practical cases like a shaft, like a ship, like an aeroplane, and other practical cases in the next lecture. Thank you.